and base development.
Okay.
7 systems were there. Out of 7, for 3 to 4 they had taken, but 4 licenses remaining. This type of message I have received.
Okay, so ma'am, can you share your screen and so that I can help you?
I had make it means 1 minute.
Yeah.
That was half an hour before, na. That's why I had taken the screenshot.
Okay, ma'am. So, like we just want a base evaluation version for the LabVIEW. So, can you start your LabVIEW? Just that can you confirm?
1 minute. Yes.
Yeah.
Yes. Yes. Can you see my screen, sir?
Not yet, madam.
Yes, sir. Can you see now?
Yes, ma'am. This is a VIPM, Virtual Instrumentation Package Manager.
Yes.
It's used for adding a driver. So it's like you need certain library files. Then so this is not needed, ma'am. You can close it down.
So this we don't need to.
We require a LabVIEW, ma'am. So can you go to your applications system? Yeah.
Yes. Yes.
And
I'm
go
going.
to the apps.
One minute. Then.
Yeah, ma'am.
App.
So there you have to select for national instrument.
App.
Yeah, in apps you can go. Yeah, NI LabVIEW 2023. I can see there. In programs, go to N, national instruments. National instruments you will find somewhere.
National. It is not there, no?
Ma'am, go to app.
Okay. I had gone to program.
Yeah.
Right. For app. After installing, actually it has been slowing.
Yes, ma'am. So maybe once you need to restart it, go to apps and go to national instruments.
There I could find that LabVIEW.
Yes, ma'am. LabVIEW 2003. I just saw it. It was there on your screen. Yeah, here there's no.
This is app, na?
Yes, ma'am. Where's program file? Yeah. Okay, scroll up, ma'am. Please scroll that up. Apps.
These many are there only.
Okay, ma'am. You do one thing. Go to the search window and type LabVIEW. Yeah, LabVIEW. Yes.
Why it is not showing? I don't know.
It's been installed.
Because I had done it. Means complete 23 point. Sorry. Yes, 23.1.
Can you see that? You can turn it off. VIPM, it's not needed now. You can turn it off. VIPM. Close it, ma'am.
From where to go then?
Just click on your apps, ma'am. Apps or in the program files you will find somewhere.
Something I had missed. Do you think?
No, I don't think so, ma'am, because there was an icon that I was able to see on your PC.
Yes, VI I could see, but I could not get that LabVIEW. And I was thinking this only that
No, ma'am. Just search it. Search for the LabVIEW. It is installed. Maybe the choice of your directory may be different. Just type a LabVIEW. Just type a lab, LAB lab. You will find something. Yeah, you can see there's a LabVIEW 20.
yes.
Yeah. Yeah, ma'am.
Okay.
It's on.
Okay. Thank you.
Yeah. You can stop sharing, ma'am.
Yes.
So I request other participants if they are having any issue with the installation or locating a LabVIEW file. So please let me know. I can help you out. Or if I believe that most of you might have successfully installed the LabVIEW. A different version may be there, but I believe that most of you might have installed it. So, can we start in 5 minutes or should we wait? Like, what should we do? Okay, so let's wait for another 5 minutes. Now it is 1:43, so around 1:48 we can start. If any other member has an issue with locating a LabVIEW file or some confusion is there, you let me know. We will allow you to share your screen and get your problem sorted out.
Hello, sir.
Yes, ma'am.
After getting to LabVIEW, I'm getting the message this software trial expires in 45 days.
Yes,
So
correct, ma'am.
activate, shall I write activate?
No, you should not activate. You should select just wait. Please
Remind me next time.
Yeah, you can show that. Remind me next time. And you can use it for the next 45 days. That evaluation version is for. So begin 7-day trial, it's showing.
Now it comes. Some add-on license expires soon.
Yeah, ma'am. You leave it there. You just
Okay.
click on begin.
Remind me next time. Okay.
Begin 7-day trial. You can run. Ma'am, you don't have such a license key for that. So activation is not possible. You can just click on begin 7-day trial. So your trial version will start from today.
Okay, sir. Thank you.
Okay, so very good morning to all very good afternoon to all the candidates. So I hope you have successfully installed the LabVIEW software. It depends, like you may run a 45 days or 7 days from a day of installation. Depends on which sort of versions you have installed. Okay, so today's session was basically dedicated for installation and seeing basic fundamentals of a LabVIEW. So I will start sharing my screen, and I will hope that all of you will follow the same procedure that what I am doing here. I will start sharing the screen. Okay. Now I will start the LabVIEW. So see, you can locate a LabVIEW in your program files, or just type the LabVIEW. Okay, so it will show that just search for a LabVIEW. So it will show I have a 2021 version. So I select it over here. Basically, in the program files in National Instruments, you can find this LabVIEW. So I double click here. So NI LabVIEW is there. So see, just remind me next time I can click here and the LabVIEW window will come. Okay, so let's continue to LabVIEW. Okay, so this is the front file that you get for the LabVIEW. So here you can see that there is a LabVIEW window. There is a file, operate, tools, help. Okay, so just go to the file. We go to the file and we select a new VI. Okay, we go to the files and select a new VI, and somewhere here blank VI or blank project is also there. We can select a blank VI over here, or we can go to file and select a new VI. Okay, so remember that in the LabVIEW, all programs are called as VI. All programs are called as virtual instrumentation. VI means virtual instrumentation. You see that a full form of LabVIEW is LabVIEW. Laboratory for lab stands for laboratory. VI means virtual instrumentation. EW means engineering workbench. So the overall, the meaning of LabVIEW is a laboratory for virtual instrumentation engineering workbench. Now, this particular programming comes under the domain of virtual instrumentation. Okay, so there is a separate domain for this particular field that is called as a virtual instrumentation. Now, many universities like a VGTI, IIT, and many universities, they run the syllabus on this particular domain, VI. Okay, so as such, a virtual instrumentation is very vast field, and there are very few programming softwares environments are there that deals with the VI. So LabVIEW is one of them. And if you see the final year syllabus for electronics engineering in Mumbai University, you will find a subject of virtual instrumentation. Okay, so this subject, virtual instrumentation, is in University of Mumbai. The subject virtual instrumentation you will find in the master's MTech syllabus of VGTI, as well as the MTech syllabus of IIT Bombay also. So VI is the field in which mostly 80 to 90% syllabus covers the programming language, that is the LabVIEW. Okay, now the programs stored in the LabVIEW are called as VI. So each program is named as VI. Go to the files, select a new VI. Okay, so I have selected a new VI. Now you will see two windows that are getting popped up. Okay, one is this gray color window. Okay, and another one is this white window. Okay, so this program has to be written in these two particular windows. Okay, now you see the gray window is called as a front panel. Okay, this particular is front panel. And what about a white window? See, if you want to switch from front panel to another, this gray window to white window, you have to press a Control E, Control plus E, E for elephant. So I press a Control E, I have switched to the block diagram. Okay, so remember there are two windows. One is the front panel and another is block diagram. You want to switch from block diagram to front panel, press Control E. Okay, so front panel is this gray color window. Press Control E. You will jump to the block diagram. Block diagram is a white color window. So white color and gray color these two particular windows are there, and switching from one window to another window is done by Control E. You press Control E on front panel, you move to block diagram. You press Control E on the block diagram, you move to front panel. Now, second important thing, okay, you want both of the windows to appear on your desktop at the same point. So the command is Control T, T for tiger. So I press Control T, T for tiger. So both front panel and block diagram appears, okay, at the same time. So half of your desktop will be covered by front panel, that is a gray screen. Half of your desktop will be covered by a block diagram, that is a white screen. Okay, so I won't call a this gray screen and white screen anymore. I will just call a front panel and a block diagram. Now I will just maximize the front panel, this gray color screen. Now in this particular screen, if we see that this particular gray color screen, a front panel, shows that how instrument needs to be controlled or needs to be operated. That means you make any program, you require a certain controls or indicator. Okay, just take a simple example. I always start the programming with a very simple example that I want to create a digital switch. Okay, some digital switch I wanted to create, and by pressing that switch, some LED should glow. Okay, so see, one thing I can do, I right click on my front panel. Okay, just right click on your front panel. Once you right click on your front panel, some controls will appear. Okay, this window will appear, just what you're observing here. Now this particular window, you see there is a numeric, there is a boolean, there is a string and path, there is a data containers, list of tables, graphs, ring and extended numericals, layout, okay, and so many functions are over here. So see, these library file depends on how much add-ons you have actually installed apart from the LabVIEW software. All these add-ons are actually available on ni.com, but most of the basic versions covers 90% of all the library that I am having now. Okay, now I'll just create a very simple program. Now see, this is a boolean. I go to boolean, where you can find a boolean. Now this is a first row and this is a second column. Okay, over here you find some boolean. Now boolean means a logic related to digital. Okay, so digital things means there are some switches are there. You can see there's a push button, there's a rocker, there's a vertical rocker, horizontal toggle switch is there, vertical toggle switch, a round LED is there, a square LED is there, some stop button, cancel button, OK button. The most important thing about these controls are, as such, they operate only at two states. One is on state and another is off state. So just like a switch can have a two position, on and off. A LED can have a two positions, that is on and off. So basically they are suitable for a Boolean logic. Boolean logic means a language of 0 and 1. So we can actually create some program using this. So all digital electronic stuffs, okay, you will find in this a Boolean. Okay, now in the Boolean, I can select a push button. I will select this push button. Now how to select this? Just now I will again show right click, go to Boolean. In the Boolean, select this push button. Just left click कीजिए. This once you left click, automatically a push button will be drag and drop. Anywhere in this window you want to place that push button, you can just drop it. Now I have dropped it over here. Okay, so it shows a Boolean switch is created. Now I move my cursor towards this. Once I select this, okay, so see some boundaries appearing across it. Okay, I can expand its size. It's not needed just because I'm sharing my screen. So my controls indicator should be enlarged so that there should be a visibility for all this stuff. So I have enlarged this switch. It doesn't make any difference even if it's a small switch. So there's some Boolean switches there. Okay, some Boolean switch I have created. Okay, now press Control E. After this, press Control E. You will find in the block diagram, a same Boolean switch is getting reflected. Okay, so I have created a one Boolean switch on the front panel and its reflection you find in the block diagram. Okay, now switch is a control or an indicator. Switch is a control. Okay, so you can control anything with a particular switch. So switch is considered as a control. Now I will create an indicator. So I right click on the front panel. I right click on the front panel. I go to Boolean. I go to Boolean, and in the Boolean, I selected some LED. Now I want LED. There is a round LED and there is a square LED. Now suppose I select this round LED. Just drag and drop, and anywhere in your program, you can drop it. So I drop it over here. Okay, I move my cursor towards this LED and I can actually enlarge its size. It's not needed as such. I can name it as a LED or let it be a Boolean 2. Doesn't matter. Okay, so there is a Boolean and there is a LED. Now let's see whether this LED is being reflected on the block diagram or not. Press Ctrl E. Now you see that in the block diagrams also, this LED is being reflected. Okay, so I just zoom this particular thing. So Boolean and LED are being reflected. Whatever I create on the front panel, that is getting reflected in the block diagram. You see, there are two things in the front panel. One is a control and another is an indicator. The switch, that's a Boolean switch, is a control. And LED is considered as an indicator. Okay, so there is a switch, there's a control, and there is an indicator. Now you see the overall structure of this Boolean and LED in the block diagram. You move your cursor to the Boolean. You see there is an arrow on the right hand side. Okay, that means a wire should be originating from this particular control. And see that on the LED there is an arrow in the completely opposite direction. That means the wire should be terminating at this particular LED. Now move your cursor, okay, to this Boolean. Automatically your cursor will change to a wire mode. You will see a icon of wire. Okay, just a left click, and you will see a wire is being made, and just connect it to the LED. Press left click and leave. You see that a wire, a green color wire is attached. Okay, so this is the connection. Okay, this is the connection now. So I have connected this switch to this particular LED. Okay. So any problem? Just once again I will show how it should be done. I double click on this wire and I delete this wire. Okay. I move my cursor to the Boolean. It automatically changes to the wire mode. I left click. Automatically a wire is being drawn, and I can just connect it to the LED. I leave my cursor. So you see that a green color Boolean icon is there, a green color LED icon is there, and a wire is also green. So that shows that a digital control and a digital indicator has to be connected with the same data type. Same data type means this is a Boolean control. LED is a Boolean indicator, and a wire is also Boolean. That shows that it's a green color. So same data type flows with the same wire. Okay, now press Ctrl E. Okay, so now this program we can run, but there is a run button over here. Now you see that there is a file. Okay, there is a file. Besides the file, there is a edit. Okay, and then there is this arrow button is there. This run button is there. You will find on the top left there is an arrow, horizontal arrow. That arrow, when you move your cursor, it shows run. So this is the run button. And just beside that, there is a run continuous. Run continuous is there. Okay, so in today's session, I don't want you to teach loops. Okay, so we will be using a run continuous for this. But normally for a single operation, we use a run. Okay, so I will press the run button, this arrow. If I press this run, you see this LED turned on. Okay, now I stop this switch and again press the run button. See, LED is turned off. I turn on this switch and run this button, this LED is on. Okay. Now there is a run continuous button just beside this arrow. Now if you press this run continuous button, now see, I can change the switch position and I can change the indicator. So for off, this LED is off. For on, this LED is on. Okay, now you can press Ctrl E. The same program will be shown. It's a very simple program is there. Press Ctrl E. So now this is our overall graphical user interface. So what you have done here, you have created a graphical user interface in which a user will deal with this switches, this indicators. Okay. Now there is a question that whether this switches or this indicators. Okay. Yeah, someone is asking, can you brief it again? Okay, so I will brief it again once, just wait. So what we have done till now is we are having a front panel and a block diagram. Okay, so I will just, those who have joined late. See that when you start a LabVIEW, you have to go to File and select a new VI. Okay, new UI you have selected, two windows will pop up, front panel and a block diagram. Okay, now in the block diagram, in the front panel, this gray color window is front panel. The switching mode is Ctrl E. Press Ctrl E, you can go to the block diagram. Okay, you press Ctrl E, you can go to the block diagram. Now, what I have done, I have went to Boolean and I have selected one push button. Push button, I have drag and drop. Again, I went to Boolean, right click on the front panel, go to Boolean, drag a round LED. I name this Boolean as LED. See, this is the first program, so let it take some time because after that, you will also speed up. Okay, so Boolean and LED, two things I have created. One is a control and one other is indicator. Press Ctrl E, you can move to the block diagram. You see, this is a block diagram, a white color screen. Okay, now this white color screen, okay, I can zoom it up and I connect it with a wire. You move your cursor towards this icon, automatically change to the wire mode. You connect it like this. Okay, so this Boolean and this LED are now being connected. Now press Ctrl E. Now where is the run button? Just below the add it, there is an arrow button. That's the run button. You run it. See, switch was in off position. It is off. You turn on the switch and run it. It's on. If you want to run continuously, just beside this arrow button, there is a continuous run. Okay. Now change your position of the switch. Off, LED is off. Switch is on, LED is on. So there is a push button and there is an LED indicator. Now question that whether this switches and LED, they are physically present? No, they are not physically present. I have virtually created this LED and switch on my desktop screen, on my computer screen. Okay, so instrumentation related to this virtually created controls and indicators are called as a virtual instrumentation. Okay, so this switch and LEDs are not physically present. I am virtually creating it. So all the programs that we make, I make a virtual oscilloscope, I make a virtual function generator. So some knobs are there, some screens are there. Everything I can create on my computer screen. My screen acts as a device. Of course, it needs a certain hardware, but virtually everything can be controlled. So all the programs that are saved in the LabVIEW are called as VI. This is the meaning of a virtual instrumentation, whether this and nothing is a physically existing. So what happens? Suppose I have some Raspberry Pi. I want to control some hardware, and in that I need a certain indicators. Okay. So indicators means I require a certain LEDs. So for a certain system, there's a buzzer or there is some LED should should be on for a certain warning message. But that's not needed with my hardware because that LED I can create on my desktop screen. Okay, and I can get a command from an hardware, and that LED will automatically turn on whenever some alarm or buzzer will go on. So this particular thing is important because the LabVIEW is in the domain of a virtual instrumentation, and virtual instrumentation reduces the cost of your hardware, overall hardware. So once the hardware components are getting reduced, so automatically you spend very less time on the delay. So automatically the delay is related to those hardware components. The noise associated with those hardware components automatically get reduced. So important thing is a processor or a controller that you can't replace, but other things you can definitely replace. So like a 7-segment display is there, some switches are there, so that job can be done by virtual instrumentation. So this program, now if you want to save this program, see there's a, after file edit view, you will see there's a red button. There's a red button. There's also abort execution. Abort execution, you just press this button and the execution automatically stops. You see so many graph appears, a graph lines, horizontal and vertical lines are appear. So that means this is a aborting and the execution. Stop the program. Okay. Now you want to save this. So go to the file and save as. Save as. Okay, this is our first program. I want to save it as led.vi. led.vi. Okay, so every program is saved in the format of .vi. Okay, so I can save it on my desktop. So just press OK, and this program is now saved. So where I can see now, somewhere here I have. Yeah, so you can find the LED program on your desktop. I don't know where it is. Internship it is. Okay, so you can save it. Now file a new VI. Okay, now next thing you want to do. Yeah, so someone is asking, can we cascade these two windows? How to remain a Boolean to LED? Okay, so see, we can cascade as such. These two windows are two different windows. Okay, now see, there is a, I will again create the same program. There's a Boolean, there is a push button. Okay, so first question someone asked me, how to rename. So see, there is some name given here. There's a Boolean. Okay, so just select on this Boolean, double click on that Boolean. So it turns black. Now type, suppose I want to write it as switch, SWITCH, a switch. Okay, you want to zoom it, just select this switch, go to this 15-point application font, size, you can increase the size, switch. Okay, now I create a LED, go to Boolean, select, let's take a square LED this time. I selected a square LED. If I want to rename it on the Boolean, I can just type LED. See, as such, no commands is needed. Okay, so just whatever name is there, a switch. Suppose this is, I want to do a push button. I can do a rename. Okay, I want to name it as a LED indicator. Just here I can type here. So like in other programming languages, you need to put a lot of commands, but here it's everything is graphical. Okay, so this push buttons, this LED indicators, we don't as such require any commands. We can just connect them. Press Ctrl E. Okay, now push button and LED indicators are there. You just wire them. Okay, Some faculties will feel a problem that the wiring is not that easy. So it depends on practice. Once you move a cursor, okay, try to move your cursor to LED and just leave that. That's it. Okay. So this was the program. Now if you want to cascade two windows, press Control T. Control T means, okay, so both windows will appear at the same time. Control T means front panel and block diagram, two windows will appear. See, these two windows can't be merged. These two are two different programs. So just like an example is, suppose I just with this, I will show that this is of a switch and LED. I will just reduce its size. Okay, now I want to create some thermometer. Okay, so I right click over here, go to numeric. I go to numeric. Now numeric sum, everything is analog. Everything is analog. No, so see that there is a meter. There is some meter is there. Okay, so you can find third last row, third column. Okay, so 1, 2, 3, 4, fourth row, third column. You can find a meter. I drag and drop meter over here. So this is some meter. Okay, some meter is there. Manually, you can change the position of this meter. Now again, I go to numeric, right click on front panel, go to numeric, and you can select, no, don't go to numeric. You can go to this graph. Okay, graph, second row, third column. You can find a graph. In the graph, you can select any chart. I select a V-form chart. Okay, I selected a V-form chart. I can put it like this. Okay, now press Ctrl E. You will see these 4 functions. So see that there is a push button, there is a V-form chart. Okay, push button, V-form chart, LED indicator, meter are there. Now, as such, we can't merge them because this programming, our code is in the block diagram. Okay, whatever you do, whatever programming you do in the block diagram. How your program appears, that is on the front panel. So just like you can imagine, you want to create an oscilloscope, a DSO. So all faculties are familiar with a DSO. So a DSO actually consists of, most important is a screen, because I observe something on the screen, DSO oscilloscope screen. So that screen is considered as an indicator. Apart from that, I want to change the time setting or amplitude setting. There are certain knobs. Okay, so those knobs, those switches are considered as this control. So a DSO consists of all these stuffs. There's an indicator, there are controls, there are some LEDs, LED indicators are there. Okay. Now, whatever your instrument looks like, you should put it on the front panel. Okay, you want a switch, you want a meter, you want a screen, you want an indicator, put it on the front panel. That things will be reflected exactly in the block diagram. You have a 10 items in the front panel, that 10 items will be reflected in the block diagram. Okay. Now, when you see a DSO, you see that controls and indicators, the switch, screen, everything outside. So just like this gray screen, this is how your instrument looks from outside. I don't know what is the logic behind this switch, how this switch and this indicators are connected, how this meter and screens are connected. Exactly, I don't know anything. But I want a particular instrument that has all these functions, these controls and indicators. I put it on the front panel. Now, you are unable to see the window from which we select instrument. See, just right click on your front panel, right click on the front panel, go to numeric. In the numeric, you will find all this. There's a meter, okay? There's a thermometer, tank. You can drag and drop as per your choice. Then you want to select a Boolean, right click, go to Boolean, and there's a push button, there's a round LED, all this thing. You want a screen, again right click, second row, third column is a graph. Second row, third column is a graph. You can select any graph, a V-form chart or V-form graph. Okay, so everything on the front panel. So The important thing is in a DSO, the screens, knobs, connectors, everything is outside, and these these screens, these knobs, these switches are connected with some mathematical logic inside. Okay, so when you get a chance to open a DSO, what you will see, the screens, knobs, switches are connected to a processor, and there is some mathematical logic that is being stored in that processor. Okay, there is some microprocessor. In that microprocessor, these all logics are being stored. So see that now everything is appearing over here. Just see, there's a waveform chart, there's a meter is there. So actual program is your block diagram. Actual program is your block diagram. A block diagram exactly gives you an idea what you can do for this particular controls and indicator. Now for you or for us, a waveform chart is an indicator because it can't take, it just takes a data. You connect a waveform chart, and whatever the data is being displayed, it will show. A meter is also an indicator. Okay, so let's make a more clear one particular program. Let's include an analog logic also. So we have a push button, we have a LED indicator. Okay, I want to remove this push button. I have, so just how you remove this push button? Just select this push button like this. Move your cursor, make a square like this from your mouse. Okay, just push button is selected and press delete, backspace. A push button is gone. Now press Ctrl E. Now see, LED indicator was there and push button is gone, but a broken wire is there. See, broken wire should not be there. You select this broken wire and delete this wire. Okay, now I want to create a certain logic. Okay, so in that logic, a waveform chart is there, a meter is there. Now let's select a tank. Okay, go right click on your front panel. You right click on the front panel, go to numeric. Okay, in this numeric there is a tank. How to select? Right click on your front panel. Okay, go to numeric, and in the numeric go to tank, last row, second last row, first column. You will find a tank. You drag and drop this tank. Okay, and you can increase its size. It's not needed as such. Okay, I will zoom it out so that it's visible to everyone. So now this is a tank. Okay, this is a waveform chart. This is a meter. Okay, and there is some an LED indicator. Now I want to rename this LED indicator. Okay, so I just write it some alarm. Okay, more than 70, something I have written. Okay, so I wanted to create an application. In this application, suppose I will take a random data. I will take some random data because right now we don't have any hardware connected with the LabVIEW. I have, but all the other participants don't have that hardware. So the last 2 days we kept for the hardware interfacing, but first 5 days we will learn the programming with some system generated data. Okay, so I will take some system generated data. In that data, I will try to design some tank management system, a tank flow system. In that, if a water level rise to above 70, so then automatically that LED should turn on. And what is the water level? Suppose in a reservoir, I want to put a flow sensor. Okay, so then if that reservoir in that reservoir, if the height of water increases to 70, so automatically the alarm should turn on. Okay, at the same time I wanted to plot that what is the level that I am obtaining. So right now we don't have a flow sensor. Okay, so because this programming has to be done to 70, so let's select everything as 100. Everything as 100. Okay, now this tank, you see this tank, Now this markings are from 0 to 10. Manually you can move 0 to 10. I want it to 0 to 100. Okay, so what you can do, just move your cursor to 10, move your cursor to 10 and double click. Select this 10 and type 100. Okay, select this 10, type 100. You see the automatically the markings are changed from 0 to 100. Okay, same procedure you do to this meter. Move your cursor to 10, double click, 10 will be highlighted, it's black. Now type 100. Now automatically the meter markings are also changed from 100. See, same thing we can do a waveform chart, but waveform chart as such they are auto scale. If a scale goes to 100, automatically a waveform chart will show the data to 100. So no need to change a data of waveform chart. Alarm LED as such we don't need it because it's just on and off state. Okay. So this is the program. This is my front panel. How my front panel looks like. Okay, this is some instrument I wanted to design. Okay, so more you practice, more you get an idea about this program. Okay, so this is one program. Now press Ctrl E. I should find out 4 controls and indicators. Okay, so there is a tank, that's also an indicator. There's an alarm LED, that's an indicator. There's a meter, that's also an indicator, and there's a waveform chart, that is also an indicator. 2 are analog indicator, the meter and waveform chart, they are analog indicator. And tank is also an analog indicator. So 3 are analog indicator, and there is only 1 digital indicator, that is your LED. Now press Ctrl E. You will find this 4 stuff in your block diagram. Okay, you find this 4 stuff. That is one is a tank, one is a waveform chart, one is a meter, and one is some alarm. Okay, now see the observation. The tank, waveform chart, and meter, they are an icon of orange color. Okay, and this alarm, that's an LED, this is an icon of the green color. So you can understand that something that is related to analog is always of the orange color, and something that is related to a boolean or a digital logic, that's of the green color. Okay, now I want some number to be generated from the system. Okay, because I don't have a hardware interface with me right now. So what we can do, we can right click on the block diagram. Now we will start doing a programming on the block diagram. Now right click on the block diagram. Once you right click on the block diagram, you can see so many functions. Okay, they are called as functions. When you right click on the front panel, you see controls and indicators. But when you right click on the block diagram, all you see are functions. Now, what sorts of functions are there? See, there are structures. Then structures you can find all sorts of loops. Okay, so यहाँ पे एक structures करके आपको मिलेगा. इस structure के अंदर सारे loops हैं. For loop, while loop, case structure, event structure, flat sequence structure. तो हमें ये आगे use करेंगे हम जब हमें for loop, while loop use करना रहेगा. Then there is arrays. Array has a huge variety. Okay, 1-dimensional, 2-dimensional, all array operations are there. Cluster class variants are there. If you want to make a cluster of 2 different data types, then clusters are there. Then there's a numeric. In numeric section, you see add, subtract, multiply, divide, all numerical operations, increment, decrement, square, square root. Okay, multiple operations related to numerics are there. And there's a Boolean operations. A Boolean operations, you see there's an AND gate, OR gate, exclusive OR, NOT gate. So many operations are there. Apart from that, there is a string, text related operations are there, comparison, waveform operations, timing, file input out, reading or storing your data. Go below, you will see a mathematics file, signal processing. Okay, so many functions, library functions are available. Now, I want certain data to this analog inputs. Okay, so I right click, I went to numeric. Where you will find a numeric? It's on the second row, first column. Okay, right click on your block diagram, second row, first column, you will see a numeric. Okay, so someone is asking, does it generate a C code in the background? See, the LabVIEW programs are they are developed with an embedded C. Okay, so if you want to generate any library file or controls or indicators, the coding is done in C. Okay, but this is now, because this is a GUI, graphical user interface, you just need to drag and drop. And if you want a C code for this, so no, because these C codes are actually hidden for a particular library functions. You can't get that, but you can run a C code in a LabVIEW because they have a C script. In that C script, you can run the code. Okay, so this is you have to go to numeric. How to go to numeric? Right click, go to numeric, and in the numeric you will find so many operations are there. Now just see, I want some data to be generated. You see the third last row, there's a random number, the pair of dice is there. Can you see it? So see, there's a divide, top row, there's a divide, then there is a multiple array, then round towards infinity, reciprocal, and there is a random number. A pair of dice is there. Okay, what number it has actually stored? It shows that okay, so it shows a random number 0 to 1. Okay, if you look closely, a random number, a pair of dice is there, and it shows number 0 to 1. Just drag and drop, and put it somewhere else. Okay, I will label it. If you want to label anything, just right click on that particular thing and visible items and label. So no need for your stuff, just for the visibility I'm doing it. See that this is a random number. Now you want to see the property of any function. कोई सा भी फंक्शन जो आप ड्रैग एंड ड्रॉप करते हैं आपके ब्लॉक डायग्राम पे, आपको उसका प्रॉपर्टी देखना है कि हाँ एग्जैक्टली वो करता क्या है. सो देयर इज अ क्वेश्चन मार्क फंक्शन. यू सी ऑन द टॉप राइट देयर इज अ क्वेश्चन मार्क. एक सर्च विंडो है, सर्च विंडो के पास में एक येलो कलर का क्वेश्चन मार्क है. ओके, on the top side top right you will find this yellow color question mark. You clicked on that question mark. I clicked. Now I move my cursor to random number. Now it starts showing the property of random number. So see how it should be done. Move your cursor to this yellow color question mark. Click there, and now move the cursor to random number. Now it automatically shows the property. Now here you can see random number 0 to 1. Now some descriptions are there. It produces a double precision floating point number between 0 and 1. The number generated is greater than or equal to 0 but less than 1. The distribution is uniform. So that means it generates some number between 0 and 1. That's a floating number. It's like 0.19, 0.35, 0.9899. So some number is generated between 0 and 1. These numbers are floating in a decimal point. Okay, now see, press Control E. Now you see that most of my program, all indicators are calibrated with 0 to 100 scale. Okay, so these are calibrated for 0 to 100 scale. So I press Control E. Now I want to make this 0 to 1 to 0 to 100. What should I do? I can multiply by 100. Any number I can multiply by 100. So 0 multiplied by 100 is 0. 1 multiplied by 100 is 100. So I get a range of 0 to 100. What I can do? I can drag and drop a multiply. Now where I can find a multiply? Right click, go to numeric. Okay, I went to numeric. Just the same point where we find this random number. Kahan pe? Second row, first column. Now you find the numeric. Now in this numeric, the first row, third column is a multiply. The first row, third column. You see add, there is a subtract, and then there is a multiply. Now you drag and drop this multiply. Try to drag and drop this multiply. See, this multiply is over here. Okay, I will label it. This is a multiplier. Now, what does this multiply do? You can see with the question mark. Now it says that there are two inputs, X and Y. And what's the output? X multiplied by Y. Now see the color of the wires. The color of the wires are orange. Okay, someone is asking, then can we deploy it on hardware? It may be on NI boards, but can it be on other boards and controllers? See, there is a complete community for the engineers that is dedicated to LabVIEW programming. Okay, so most of the there's almost all embedded hardwares are now being controlled by the LabVIEW. So your ARM processor, your Arduino, Raspberry Pi, okay, and this Jetson Nano, NVIDIA, all these hardwares can be controlled with the LabVIEW. So it's true that National Instruments have their own hardwares like NI DAC boards are there, data acquisition boards are there, data acquisition cards are there, NI My Desk are there. So they provide you a very, very good flexibility. Okay, but you can control any third party's hardware, any third party hardware that is not developed by National Instruments with the LabVIEW. Okay, so it started with the developing of one software, and then some add-on hardwares keep on being introduced to have a more professional and fast working. But as such, I know that NI community engineers have developed the drivers for all third-party software. So, like suppose in your institute you are having a Tektronix or Agilent DSO, or suppose you are having a Tektronix function generator. So Tektronix, Agilent, okay, Keysight, all these are third parties. Okay, they are not a National Instruments product, but still you can control these function generator instruments with your LabVIEW software. As far as the students are concerned, so students normally use that Arduino boards, ARM processor, okay, or a Raspberry Pi. So that can also be controlled with the LabVIEW. So these drivers are there. And if you clearly see that in our chat files, okay, we have shared some links. So in the chat, we have some WhatsApp group. In that WhatsApp group, we have given a Google Drive link. In that Google Drive link, you will find the LabVIEW software as well as a hardware drivers for Arduino, USB cables, other things. So any third party can be interfaced with the LabVIEW. Okay. Now I see the multiply. So multiply, you see there is X and Y. Move your cursor to the input of multiply. There is X and Y to input, and output is X multiplied by Y. Now move your cursor to X and move towards the random number. Just connect it. So your X is now connected with this multiply. Okay. So see that now the color of this particular wire is orange because it shows the analog data flow. Okay, no more zeros and ones, but a random number between 0 and 1, some decimal point will be generated. Now this 0 and 1 has to be converted to 0 to 100. Now how to create 100 on Y input? So I move my cursor towards Y. Okay, move your cursor towards Y and right click. Move your cursor towards Y and right click. Some palette will appear, and in that palette you see there's a create. Okay, from bottom it is the fourth. Okay, so आप देखेंगे there's a create constant, control, indicator, visible item, help, example, numeric palette, create. Okay, and you go to create a constant. Create a constant. I will again show. Move your cursor towards the Y input of a multiplier, right click, go to create a constant. Okay, so automatically a 0 will appear. Okay, now this 0, just move your cursor, double click on this 0 and type 100. Type 100. So automatically this number becomes 100. So 0 on 0, आपको 0 पे type करना है 100, so automatically it is 0 to 100. Now 0 to 1 becomes a 0 to 100 by multiplying, and now give this output wire to tank, waveform chart, and meter. So I give this output to tank, to a waveform chart, okay, and to a meter. Just see. So a random number 0 to 1 produces any decimal point number, floating number between 0 and 1. It gets multiplied by 100. So it becomes a 0 to 100, and that 0 to 100 random number is being displayed on 3 indicators. That 3 indicators are waveform chart, tank, and a meter. Okay. Now I have a fourth more thing. There's an alarm that's more than 7. There's some LED indicator. There's a Boolean indicator. Green color wire is there. Okay. So now how to connect this particular orange color wire to the green? Okay. So in that case, we have right click, go to comparison. So right click on your block diagram. Okay. You will find the structures, first row, first column. First see the first column only. There's a structures, there is a numeric, and just below the numeric, there is a comparison. Okay. So it's a third row. In the third row, first column, you will find the comparison. Now in this comparison, now you can see there's a greater, okay, or greater or equal. So in the first row, you will find the equal, not equal, greater, less, greater or equal. So it's totally up to you whether you want to select a greater or equal. Because our system says that whenever a water flow goes over 70, the alarm should turn on. So I am selecting a greater or equal. Okay. So I drag and drop this greater or equal over here, somewhere here. I will just label it. Okay, let's put it somewhere here. Now see the property of greater and equal with the question mark. What does this say? See that these greater and equal have a two input wires that are X and Y. And they are of the orange color. So it takes a data analog inputs. And see the output, that's a green wire. So output is green. So returns true if X is greater than or equal to Y. Otherwise, this function will return false. So there are only two things possible. Either this number will be more than 70 or less than 70. So there are true and false. Two states are there. So automatically output is going to be a Boolean in nature. Okay. So then this is the way we can actually have a analog input and a digital output. Okay. Now one wire X should be connected to this. I connected one wire of the X to this indicator line, the line that is giving a waveform chart, meter, and tank. I connected this line to greater or equal. Now on the right, greater or equal to what? I want it greater or equal to 70. So then again, I move my cursor to Y input. Move your cursor towards the Y input of greater or equal and right click. Once you right click, go to create. And again, we will repeat the same procedure, create a constant. You will right click, go to create a constant. So now this is there. So 0 will appear. I will zoom this 0. Okay. Now just double click on this 0 and type 70. So greater or equal to 70. And then because its output wire is going to be green, I can connect it to this green alarm. Okay, so this was the very, very simple program. Exactly what we have done here. See, we have generated, first we go to front panel. Press Ctrl E, we go to front panel. I have selected a certain indicators on my front panel. This is how my program should look like. What controls and indicators I want? I want a tank, I want an LED, I want a meter, I want a data chart, a waveform chart. Okay. And condition for LED is whenever my data goes more than 70, this LED should turn on. Okay, I have calibrated my tank from 0 to 100. I have calibrated my meter, everything from 0 to 100. I press Ctrl E. This tank, waveform chart, meter, and alarm LED. are being reflected in your block diagram. Now, what logic I have applied? I have selected random number. Okay, a random number from numeric. That random number I multiply. The multiply also was taken from the numeric. So 0 to 1 multiply by 100 becomes a 0 to 100. Some data, you can do a 0 to 500 also by multiplying with a 500. You can do a 0 to 1 multiply by 10 becomes a 0 to 10. Then you need to calibrate your indicators accordingly. So now the number is 0 to 100. Now give it to a time, give it to a waveform chart, give it to a meter, and I use a greater or equal. What's a greater or equal? It takes whether x is greater than or equal to y. If x is greater than or equal to y, it will return a true value. Otherwise, it will return a false value. Okay, so this was it. And how to create this 170? Right click on the y terminal, create constant, type 100. Here also x greater than y. Right click on your y terminal, create constant, type 70. Okay, so this is being done. Now, let's run this program, but I want to run it continuously. Okay, because I don't want to have any one data. Suppose a number is generated is 0.5. 0.5 multiplied by 100 is 50. Now 50 means 1 point will be displayed, and so this thing I don't want. I want it run it continuously. Run it continuously. So just near the arrow button, just below the edit, there is a run continuous. Okay, press this button. It will run very, very fast. You see? Actually, on my screen projection, it looks slow, but it is very, very fast. And it's very difficult to see whether what value is being generated, but some values are being generated. Okay, so I stop this program for a moment. So there's a red color button about execution. Okay, now I wanted to modify this program slightly by using some programming concepts. Okay, so in that case, let's control E, because I want a certain delay, because the program runs very, very fast. So it's very difficult to observe the values, exactly what values are being there. So I can put the complete program inside a loop. Okay, inside a loop. So if I put a program, if I want to repeat a program multiple times, I can put this program inside a loop. There are two loops, for loops and while loop. So just like in C programming, the for loop and while loop are being used in LabVIEW also. Okay, so we can do one thing. Right click on the structures. Okay, so block diagram पे right click कीजिए. So you right click on the block diagram, go to structures. Now in this structure, you will, in the first row itself, you will find a for loop and a while loop. Okay, so right click on the block diagram. First row, there is a structures. In the structures, you will find a for loop, you will find a while loop. Now, the difference between two loops, for loop and while loop, is for loop runs for a fixed number of iterations, but a while loop runs for an endless iterations unless until it is stopped by some external condition. I wanted to select a while loop. Okay, let's select this while loop. And now see carefully that how this while loop is being created. Now my cursor is there. I will make a square so that whole program lies in that square, just like this. Just like this, see here. And I leave this square. Automatically, whole program is now inside the while loop. How it should be done? I will remove this while loop. Go to structures. First row, first column, you will find the structures. First row, second column, you will find the while loop. Select a while loop, move to your top left corner, move your mouse, left click, and drag, increase the size of this square, or make a rectangle like this, and put it like this. Leave here. Now see, this complete program comes inside a graphical loop, that is your nothing but a while loop. That is a while loop. So while loop runs endless iteration of the times unless it is stopped by some external condition. So see that this program is complete graphical. You don't type. Okay. Okay. Just wait. Okay. So now see that here, when you observe the arrow button, now observe the run button. File is there, edit is there, and there is a run button. Okay. That run button is broken. Press Ctrl E. Press Ctrl E, move to the front panel. You will find this run button is broken. This run button is broken. That means there is some error. See, this run button should be complete white, unbroken. Okay. If this run button is broken, that means you are having a certain error in this program. And that error is nothing because you are having a program inside a while loop and you don't specify the condition. Because it will run endless number of times, it should be stopped by the user. So you see that there's a at that bottom right, there is a red color terminal. It is called as loop condition. Okay, at bottom right, there is a red color terminal that is called as a loop condition. So right click on this loop condition and create a control. I will again show. There's a while loop, bottom right, you will find a red color button. That is nothing but a loop condition. Right click on it, create a control, and automatically a stop button will appear. You see, there is a stop button that is attached to this loop condition. Press Ctrl E. Now you can see a stop button at top left. Okay, you can see this stop button at the top left. That means whenever you want to stop this program, whenever you want to stop this endless loop operation, you have to press this stop button on the front panel. Press this stop button, a loop operation will stop. Okay. Now I press Ctrl E and now see that a broken arrow becomes a clean arrow. See the run button. Run button now becomes a clean run button, unbroken. So that shows that now whatever error was there, that was eliminated. You have eliminated that source of that error. That error was nothing, but because you did not specify a condition for a loop. So we need to be careful which sort of loop we are using, whether a for loop or while loop. Each loop comes with a certain condition. Okay. For loop requires a number of counts. You want to run that for 50 number of times, 100 number of times, 1000 number of times. But a count has to be fixed. For loop requires that count. While loop, because the operations are going to be endless, so while loop only requires a one stop button. That has to be a user generated. Now press Ctrl E. Okay. Now we don't use a run continuous because now we have actually made a while loop. So we will use only the run button, this arrow button. Okay, I use this run button. Now see, the program is running very, very fast, very, very fast. Okay. So this is the one thing that I wanted to explain, that there is a looping operation. Okay, now I stop this program because it's very difficult to observe what sort of values are being generated. I press Ctrl E. Now I want to delay this iteration. See, there is a first iteration, second iteration, loop operation, third iteration. Suppose this loop runs for suppose a 10 crore number of times. So there is a 10 crore iterations, but I want in each iteration there is some delay. I want to put a delay. So what I can do, I right click inside the loop, anywhere inside the loop, anywhere right click. Once you right click, you see there's a timing. You see there's a watch. The watch is on the fourth row, second column. You will see a watch. It's written as timing. Okay, it's very, very easy to observe. So when you right click on your block diagram, there is a fourth row, second column. You will see a timing. There is a watch. And in that timing, the last row, first column is a time delay. As such, this all are delay. Okay, so in next 6-7 days, we will use all different sorts of delay. But I wanted a simple delay. This is a time delay. So I will again explain. Right click, go to timing. In the timing, select this time delay. Time delay, third row, first column. Select this time delay and put this time delay anywhere inside the loop, anywhere. And just put it over here. Just like a hanging on a wall. Okay. Now it shows the time delay 1.000 second. That is a 1 second. So between two iterations, there is a delay of 1 second. But 1 second is a huge. I don't want that slow system. So I can select this one and I can put a 0.2 seconds, or let's say 0.3 seconds. So 0.3 second means 300 milliseconds. So I want between two iterations, there is a delay of 0.3 or 0.2. Okay, let's say 0.25. So 250 milliseconds between each iteration, and I press OK. Now it's set. See, this delay, time delay don't need to be connected. You made a one graphical loop, and in that you put like a time delay as a hanging somewhere on the walls of the loop. Now press Ctrl E. Okay. Now before you see this color of this waveform chart is white. Okay, whatever data is being stored is white. I want to turn into I want to change the thickness of this line as well as the color of this line. So this is a plot 0. Somewhere here, this is a plot 0 and some line is there. Okay. You select near the plot 0, there is some line, a white color line. You select on that, left click on that white. So it shows the color, which color you want to have. Suppose I want to have a green color. So I can select a green color. And I want to increase the thickness also. So again, I click on this line, plot 0, and there is a line width. Now, how much width you want? I can select the width. Okay, so this is just some representation of data. It's nothing related to a programming, but it's just representation of data. And I run this program now. So now my program will be delayed by 250 milliseconds between two iterations. And clearly I can see these values. Now see, I'm running this program. So it's closely, we can observe. See that whenever the output goes more than 70, the LED turns on. Okay. Whenever an output goes more than 70, the LED turn on. The tank shows the same output. The waveform graph also shows the same output. So some plots are being, so what does a random number is doing? Random number keep throwing the number in between 0 to 1. Suppose 0.78, 0.68, 0.25, 0.37. Some numbers are being generated. That number getting multiplied with the 100, and then that is being displayed on tank, meter, and waveform chart. And whenever that number exceeds the 70 or equal to 70, then automatically the LED is turning on. So see that this is a combination of an analog and digital inputs. Okay, our front panel as such have some analog indicators and a digital indicator. And there is a block diagram that's connected with certain logic. Okay, so as such, these analog screens, you can see that I don't require a DSO now. Now suppose on your last day or second last day of this FDP, you will connect an Arduino or Raspberry Pi to your system. During that time, you won't require an oscilloscope. Suppose there is a temperature sensor or pressure or flow sensor, you want to monitor that, you will directly observe the same thing on a waveform chart created on your front panel. Okay. So as such, no external display indicators are required. All indicators we can generate on our front panel itself. So front panel is as such how our instruments look from outside. Better say how our virtual instrumentation look from outside. And what is the real code? Press Ctrl E. This is the real code. That's called as coding. Okay. So this programming is called as a G programming. That's a graphical program. So LabVIEW engineers, they don't write a program, they draw a program. Okay, it's a G programming. It's called as a graphical programming. Okay, so now you want to change the color of plot, you can do easily. You can select the colors. You can make this plot as red if you want. Okay, you can make it a blue. So it's totally as per your choice. We can have a multiple signals. So 4-5 days, you will learn more about the programming environment, and then we start using the hardware. So as such, this programming language is basically made for hardware interface and made for an automation. So it's an industry software. So if you have multiple times, you might have visited industries during industrial visits or some research work. So you will see that most of the plants control, okay, whether it's a temperature, flow, pressure. So they don't connect an DSO at every point. Okay, they just have a one data acquisition DAC hardware, and from that DAC hardware, they have a LabVIEW software, and in one screen, one computer screen, they are able to observe the parameters of overall plant, complete factory, complete industry parameters they can observe in one front panel. So this is there, like you can have all the values, you can have any sort of indicators, controls. Okay, so this is like a creating a virtual instrumentation. So this screen, meter, tank, indicator system, LEDs, these are not a physically present, they are virtually created. Okay, and we are giving a user a GUI, a graphical user interface. So then you create this GUI, then in the block diagram, you program this GUI, okay, by just a drag and drop, and you can do it. Now you can see that how easy it was to put everything inside a loop. You can see a while loop. It's how easily a complete program was made inside a loop. I just made a rectangle, okay, put a stop button and done. When you do it in a C or in a MATLAB, then you require like a lot of loop. Then you have to initialize your n equal to 0, then n plus plus increment you have to do. You have to made a final value, and then so many loops are there. So here also in loop inside a loop is very much possible. How much easy operation was a delay? I just put a time delay inside a loop, and you see a graphical visibility. I see a computer code, I see a C programming code or a MATLAB code. There's a complete text based. Okay, syntax is required. Now, if I see here, I can directly understand there is a random number being multiplied with the 100. Okay, these are being displayed on these three indicators. Then a one wire that is connecting a greater or equal, whether it's more than 70. If it's true, then alarm will glow. If it's false, then alarm won't glow. Whole operation is inside a loop and with some certain time delay. Very easy to understand the flow of this data. Okay, this is called as a modular programming. So a particular part of the program, where to start, where to end, these all operations are actually present in this particular software. So this was the one very simple program. Okay, now we wanted to see the highlight execution. Okay, some certain programs are there. See, this is an arrow button. Just go to the block diagram. We will see the block diagram. There's an arrow button, there is a run continuous, there is a abort execution, there is a pause. Okay, and then there is the highlight execution. There's a bulb. You will see a bulb. Okay, there's a bulb that shows a highlight. So near view, project, and operate, just below the project, you will see a bulb. That bulb is highlight execution. Now press this bulb, it will turn on. Okay, it will start glowing. Okay, this start glowing. Now run your program in the block diagram, not in the front panel. Okay, now अभी आपके जो ब्लॉक डायग्राम का जो एरो बटन है, ब्लॉक डायग्राम का जो रन बटन है, वो आपको प्रेस करना है, फ्रंट पैनल पे नहीं, ब्लॉक डायग्राम पे. सो आपको पूरा डेटा point by point, which value is being generated, which value multiplied by 100, what is the final output, and whether the greater or equal is returning a true or false value. That everything we will see. Now highlighting an execution will actually slow down your program. Okay, it will slow down, but it requires wherever we want to see the error. So I run this program. Now see, value is 0.53. Random number being multiplied by 100 is 53.44, and then it is being displayed. Now next number is 0.78. Next number is 0.80. Next number is 0.34. And see the LED is returning a false value. Now it's returning a true value. So at every point we can see that what is the state of our data, how our data is getting modified, how it's flowing. Suppose it doesn't give you any data, but it has written ERR. That means an error is being generated at this module. So LabVIEW engineers, what they do, they highlight execution, they highlight this execution and run the program in the block diagram to see the flow of data, and exactly they get to know that which particular hardware module is not functioning properly and that need to be replaced or properly checked. Okay. Now, most of the time it is found that a programmer click this highlight execution and then forget to turn it off. So what happens? The program is automatically delayed. Okay, so never forget to turn off this. So it was in off position. Again, click it, make it in off position. Okay, press Ctrl E. Now this is a program. Okay, this is stop. I stop this. If now I wanted to stop this, I won't put this abort execution button. I will just use the stop button created by the loop. I will stop this. Our program stopped automatically. Okay. Now there are two states of this LED. This was a green color LED. So you see that when it turn on, it's a light green. When it's a turn off, it's a dull green. Okay. I want to make it a red when it's turned off. So red for off and green for on. Just right click on this LED. Right click on this LED. First stop the program. Never fail to stop the program. Stop this program. Right click on this LED. Go to properties. You go to properties. Now see there are colors. So light green, a bright green for on and dull green for off. Just select on the off. Click on the off. Select the choice of your color. Normally I said select as red. Okay. And I press OK. So now off position will be indicated by red and on position will be indicated by light green. Now I run the program. Okay. So automatically you can see the on and off positions. So whether the data is going more than 70 or not. Okay, one more thing. Now, see, all representations are in terms of tank, meter, or graph. There should be a value that should be displayed. A value has to be displayed. Okay, so I will create a numeric indicator. So just right click on your front panel. Right click on your front panel, go to numeric. Go to numeric and select a numeric indicator. Don't select a numeric control. I want a numeric indicator. Right click on your front panel, go to numeric and select a numeric indicator. First row, second column. Now this numeric indicator is there. I will zoom out and I can write here a value. Okay, I have generated some value. Now press Ctrl E. Now this value is there. I will give it to a tank or any output. I will just connect. I will create a one more wire. Okay, so it doesn't change anything in my program. Now whatever number was being generated, that is displayed on a meter, a waveform chart and tank, and also as well as a numeric indicator value. Only that change, that addition change I have done. Okay, so now I am having a 4 analog indicators, 1 digital indicator. Okay, now I press Ctrl E. I run the program. See, the value is being displayed. Whenever a value is more than 70, automatically green light turns on. So that value is actually multiplied by 100. So whatever my random number is being generated, that is being multiplied by 100 and being displayed on a value, meter, tank, and a waveform chart. Okay, so as such, programming becomes a very easy when you create a graphical user interface. So this is a GUI. The program is a G programming. Okay, graphical programming, in that we don't write anything, we just draw anything. So many times it is found that you can have a very attractive front panel, but when you press a Control E, it's a very simple program. So many times it looks like it is like a very big complex programming is being done, but that's not a case. Very simple, just a drag and drop functions are there. Now see, the same function is available in the MATLAB Simulink also, a drag and drop sort of thing. They also have some virtual oscilloscope and virtual screen and everything. But the difference between a LabVIEW and a MATLAB Simulink is the MATLAB Simulink doesn't allow you to interface with the hardware. Okay, but this is basically programming language that is made to control the hardware. You can always do a simulation. A MATLAB is very good for the simulation. Okay, but when it comes to the hardware interfacing, there are very few options are available. But LabVIEW can be interfaced with the any hardware. Okay, it can use the camera of your PC. Okay, there's a web camera attached to your PC that can be used. Okay, and it can be used the audio jack of your laptop or mobile. So any voice data it can take from your laptop, from your mobile. It can use the speaker of your mobile or a laptop. So anything can be planned with the LabVIEW. So not only some external hardware, but some hardwares are attached with your laptop or mobile also. So you can make use of, like, I can give a sound input. How I can give a sound input? With some audio jack or a microphone. So that option is there. So I don't need to connect an external hardware. Just I can use the hardware given in your PC. And there is a speaker available. There is a USB port available. Serial port is available. Okay, web camera is attached with your laptop. So then we can easily interface with these things and we can do a good programming. So this was the how your program looks like. Now see that there are certain data types. Okay, so let's come to some data types. I will just increase it. Okay. Okay. So you see that one data type is the analog data type, so in which the icons are also analog and the wires are also related to analog color orange. So icons and wires are orange. Another data type is a digital data type that is of the green color. Okay, this is of the green color. Apart from that, we have a third data type, that's a string. So I will create one simple program, new VI, and I will show the different data types. Okay. So see that I created a numeric control and I select go to numeric, I select a numeric indicator. One is a control, another is indicator. I go to Boolean, I select a push button. I select a LED. Again, I go to Boolean. I select a round LED. Okay. There is a third data type. That's a string. I go to string and path. So string and path you can find here. String and path. First row, third column. Okay. So there's a numeric, there is a Boolean, and just beside a Boolean, there is a string and path. In the string and path, you can select a string control and string indicator. So select a string control and select a string indicator. I'm just trying to show you a different data types. Okay, so on the left hand side, there's a numeric control. I can write down some number. Okay, that number should be displayed in the numeric indicator. This is a Boolean switch. I can turn it on and off, and accordingly, I can program this Boolean. And there's a string. String is related to text. I can type here, so I can write here. Thakur College of Engineering and Technology, Mumbai. Any string I can type here. Okay. Now I press Control E. To see that you will get an idea of different data types. These are the different data types. Now see, a numeric control and numeric indicators. They are of the orange color. And connecting wire is also orange. A Boolean control and a Boolean indicator, they are of the green color. And connecting wire is also green. A string control and a string indicator of the pink color, okay, or magenta color, and then connecting wire is also pink. So see that these three are most popular data types in LabVIEW. Okay, so why these are different color icons and different color wire? Because you should not be connecting a string to a Boolean logic or Boolean to a numeric logic. Okay, automatically it gives you error. For example, I delete this green wire. Okay, I delete this orange wire. Now I try to correct this Boolean control to numeric indicator, this green control to orange indicator. It shows me a cross, can't be connected. Try to connect this numeric indicator to this Boolean. It shows cross. Okay, so connecting a different set of data types is not allowed. Now in our last programming, what we have seen, we have connected a greater than or equal. Some analog inputs were there and output was digital, because it's a property of greater or equal. Greater or less than का क्या property है? या तो वो true value return करेगा या फिर false value return करेगा, तो उसका output digital ही होगा. So इस तरह के कुछ exceptional cases हैं जहां पर analog input है और digital output है, but everywhere we can't do that. So you need to remember what sort of data flow is there. That's why this LabVIEW has actually made it much simpler, that you should understand your data and accordingly you should wire them and use your logic. So these three are the most common data types. Suppose some waveform graphs or charts are there, so that that graphs is shown with the orange color. Okay, and apart from that, there's a numeric. Yeah, so since see this is a numeric constant. So whenever some whole number is there, so suppose numeric constant is there, I wanted to create a numeric indicator. See, some whole number is there. like a 3, 4. That 4, 3 is shown with the blue wire because it's a whole number. Or suppose that number is a floating, like a 3.2, 4.9, like that. A decimal point is there. So then that wire is shown with the orange color. So if the number is a whole number, just like a loop iteration, okay, a loop can execute a 2 times, 3 times, 10 times, 20 times, 1000 times, but it can't execute 100.21 times or suppose 35.45 times. Like that is not possible. A loop operation always happens in whole numbers. So that's why loop iteration is given with this blue color. So this is also one sort of wire. So that's a blue color means a whole number, but analog. If its floating point number is there, then this is a orange color number is there. Okay. And apart from that, as such, I don't think, yeah. That we can see later. So these 3, 4 data types are there. You should remember their colors. You should remember their pattern. Okay, now let's run this program. So I turn this on, run this program. You see that 1, 2, 3, 4, 5 was written. 1, 2, 3, 4, 5 is reflected. This switch was on, so LED turned on. I wrote a Thakur College of Engineering and Technology, Mumbai. The same was reflected on a string. And I connected this number 4 to numeric indicator, and 4 is reflected on numeric indicator. So you need to remember these different data types of the LabVIEW. So it becomes very, very easy for the programming. So normally students make a lot of mistake in connecting a different data types, and then they complain that our logic is correct, but still a wire is not getting upset. The wires are not getting connected. So this is the one case. Second case is you can't connect a one-dimensional array with a two-dimensional array. Okay, so the thickness of wire decides whether it's a one-dimensional or two-dimensional. Very thick, very thin wire is there. So data is one dimension. If the thickness of this wire has increased, so it becomes a two-dimensional. Okay, so that we will study more in the arrays. Once we get to know about the arrays, so we see the thickness of the wires getting changed when there is an array, a one-dimensional or a two-dimensional array. Same with the Boolean, same with the string. Okay. And let's come to the palette function. So you see that now in the LabVIEW programming, first thing, most important point is LabVIEW stands for Laboratory for Virtual Instrumentation Engineering Workbench. All programs are called as VI. So you are supposed to write a VI. Write a VI for a temperature control, write a VI for flow control. Okay, like this. Second point, there are two panels, front panel and a block diagram. Now this is the front panel. Okay. See that this is the front panel and this is block diagram. So there are two panels in the LabVIEW, front panel and block diagram. Switching from front panel to block diagram is done by a command Control E. Okay, press Control E. You can switch from front panel to block diagram. Press Control E. You can switch from block diagram to front panel. Next thing, if you want both of them together, press Control T, T for tiger. Press Control T, half of your screen will be front panel, half of your screen will be block diagram. So there are two commands, Control E and Control T. Now talk about the palettes. Okay, so talk about the palettes. So when you right click on the front panel, all you get a control palette. You see the name of the palette is control palette. So this control palette, all you find is the controls and indicators. How your instrument should look from outside. Okay, controls and indicator. Any instrument, your microwave, oven, okay, or your air conditioner, your refrigerator, TV, everything from outside is only the control and indicators. From inside, there is a processor, there is some logic, mathematical logic for that. Some programs are there. So when you right click on the front panel, you get a control palette. Press Control E. When you right click on the block diagram, all you get is a function palette. Function palette means all mathematical operation, arithmetic operation, arrays, clusters, structures, shift registers operations, all these things are there. So there are two palettes, control palette on the front panel and function palette on the block diagram. Apart from that, there is a third palette also. Okay, so some books mention about this, some book don't consider it as important. So that is, go to view, file, edit, view, and then there is a tool palette. Okay, if you go to view and select the tool palette, then tool palettes will appear. See, this is just like a changing your cursor to hand, writing a text, okay, editing, more like a decoration things are there in this. So now this panel is gray, I want to make it a white, so I can do it with this tool palette. Okay, so different sort of things are this. You see the VForm charts background is black. I want to make it a white so that I can do with this tool palette. But I prefer not to use it because unnecessary. See that whenever my cursor is moved to particular control indicator, it changed to hand mode. Okay, from cursor to hand mode. So for that, if suppose you are not having a mouse, okay, tool palette is basically designed for those who are not using a mouse or those who are not having a mouse. So if you're not having a mouse, then it becomes a very difficult with your finger, you have to move everything. So then you can use this tool palette. There's a wiring option. There's a changing the background. So just like connecting with this thing. So there are such three palettes now. Front panel पे क्या है? Control palette है. Block diagram पे function palette है. And then दोनों ही front panel और block diagram में एक tool palette. So three palettes are there, but most important palettes are control palette and function palette. After that, we have seen about the data types. Now these are the data types. You can identify the colors. So there's orange, there's green, and there's a pink. Three different data types are there. If number is a whole number, but are not digital, analog whole number is represented with the blue wire. A thickness of the wire decides whether the data is a one-dimensional or a two-dimensional. Okay, so these things are there. So we have done three programs as such, and we can always modify our program as per our requirement. Apart from that, there's a highlight execution which I have shown. What is the purpose of highlight execution? This bulb is there, you press this bulb, automatically you get a flow of data. At what point, what value is being generated? So at each point, you need to find it out that what value is being displayed. So that's automatically getting displayed on at every library function of your LabVIEW. So highlight execution, always turn it on when you want to find out the error. But after you find out the source of error, please turn it off. Otherwise, unnecessary, it will make a program very slow. Okay. Then there is a time delay. Time delay is mostly used inside the loops and case structures to delay that particular iteration. So now you see that in this while loop, okay, in this while loop, there is I. Okay, and that is of the blue color. So I shows the iterations. So iterations means a zero iteration, first iteration, second iteration. So loop counts are there. Suppose this loop is going to be executed at 10,000 times. So that count has to be I, that has to be in a blue color. That means a 0, 1, 2, 3. You can't have a 5.9 counts or 2.7 counts of a loop. So this I iteration actually shows the loop count. Okay, so this topic I was about to teach as a separate loops and loops, structures, clusters, case. So I just touched the while loop operations now because it was needed. And all programs that are being stored is basically called as a VI. Okay. Apart from that, a LabVIEW gives you the flexibility of setting up a remote lab as well as a virtual lab. So I think you can understand the concept of a virtual lab. Virtual lab means a student don't have a devices with them. Okay, very limited devices are there. And in that you can actually design a user interface program. In that you can change the value, you can allow the student to use this graphical user interface and simulate a certain data, because you are having a chart, you are having a certain sliders. Okay. So setting up a virtual lab is very, very easy with VI, virtual instrumentation. So many faculties get confused with a VI and a virtual lab. Virtual lab is a different concept, and virtual instrumentation is also a different concept. Virtual lab actually requires nothing to be connected in a real world. Like you can do a chemistry experiment on a virtual lab. Your desktop will show something, some chemical being added with another chemical, and some reaction is happening. Okay, without any chemistry setup. But here actually you can use a virtual interface to connect with a real hardware setups, or you can have a complete simulation programs also. So LabVIEW helps a lot in setting up a VI. Apart from that, because of this flexibility of user interface, a graphical user interface, students or like universities, they widely prefer these particular software for setting up a remote labs. Okay, so because this LED indicator meters, they can easily drag and drop, and that program can be given to a student and remotely via an internet cable, you can connect your device to this particular program with a dynamic IP, and you can have a remote access operation. So that's also now most of the labs, most of the advanced institutes are doing, setting up a remote lab. So 50% job is actually done, becomes very easy when you are using this particular tool. Okay, and apart from that, I just wanted to give one overview about some examination. Just wait. Okay, so this was the certified examinations available as such. I think this is an old slide. Just wait. Yeah, over here. This is the new one. So the national instruments require a professional certification in the LabVIEW courses, and they have a certain standards for a LabVIEW programmers. So if anyone wants to make his career in real industry, so then there are certain certification level. So that one is the CLAD, Certified LabVIEW Associate Developer. The exam is called as a CLAD. Okay, so these you can clear. This is the element, the basic level examination. So anyone who knows the basic LabVIEW can try for this particular examination. This examination is completely multiple choice. Some fill in the blanks and true false questions are also there. Mostly test your IQ. Okay, about the fundamentals of the LabVIEW, just like a data types, loops, charts, all this stuff it asks. CLD validity is for 2 years. You clear it today, it's valid for 2 years. And most of the companies, if you find in the LinkedIn ID, they require a CLAD or CLD certification. Okay, so many students, they made their career in national instruments by clearing a CLAD examination. It's basically like students who are making their projects in LabVIEW, they can easily clear the CLAD exam. The next one is a CLD, Certified LabVIEW Developer. See, these particular examination requires a project to be completed. And duration of this example, the duration of this exam is also more. 5-6 hours, maybe 8 hours. Some problem statement, a big project is given, and you have to complete that project in that duration of day. Okay. CLAD, you can go to ni.com, www.ni.com, and you can apply for a CLAD over there. They will give you the venue. So venue anywhere in the in India, you can select, but mostly preferable metro cities, Mumbai, Pune, like that. Those center, Nagpur, these centers are there, and you can select the time, morning time, afternoon time. You can go to the center, you can appear for the examination. You have to go to the center. CLD is also, you have to go to the center, you have to appear for an examination, you have to appear for a project. Then third one is a certified LabVIEW architecture. Okay, this is another higher level advance. You can't appear for this CLA unless until you have cleared the CLD. Okay, so some faculty was asking me whether we can actually develop the CA codes or like this. So if you can have if you know have a good command on C, then you can use an embedded C and you can bring the library functions and you can actually develop the LabVIEW code. So CLA architecture means developing a library files for the LabVIEW committee. And the last one is a CLED, certified embedded system developer. That means if you are very much thorough in embedded systems and it's hardware interfacing, so then this particular exams are there. So it actually tests your knowledge of controlling an embedded system with the LabVIEW software. Okay, apart from that, there is a test and architecture. These are more like a VLSI and microelectronics related stuff. But these four, CLAD, CLD, CLA, and CLED are considered as a benchmarks for engineers. Okay, and once you complete this examination, then it's like a very good value you have as far as the hardcore industries are concerned. So I believe that during this 7 days course, we can have a CLAD syllabus covered, at least CLAD syllabus covered. And if your students are making a project in the LabVIEW, then they have a good chance of clearing a CLD, but that requires a lot of embedded interfacing also. So I think these two, CLAD and CLD, are very much in our capacity, and it's my initiative that for the students and faculties to get skilled knowledge in this two particular examination. CLED charges us 6,000 to 7,000 rupees for an examination. CLD charges some 25 rupees for the examination fee. So it's not like that you can just appear for the examination, you choose your center. You have to pay some examination fee and you have to go. But certification value is very, very, very high. You're having this particular certificate, then you are actually a certified LabVIEW developer and you have a very good chance of making a career in industry. So it's very good for the students as well as for the faculty collaborations who are doing the projects. So in our case, we do a lot of collaborative projects with TFR, BRC, because we have this much skills, manpower skills related to in this programming in terms of faculties as well as the students also. So I guess now from today's session, we have a brief overview of a LabVIEW, what sorts of functions, controls are can be made in LabVIEW. What is a front panel? What is a block diagram? What is the instrumentation? What's the programming? We have seen the number of palettes. Okay, there's a function palette, control palette, tool palette, and then we have seen different data types. Okay, different data types, array functions we have seen. So totally like it's totally up to you, like at what level you want to try. But basically in this programming, we will see a lot of user interface can be made. Okay, so any questions are there in today's session? I am open to answer them. So any questions I will like to answer, like you have.
Arpit sir, am I audible?
Yes, ma'am, you're audible.
Yeah, Arpit sir, we have seen, I mean, this how to create systems for electronic instrumentation. But is
Mhm.
it possible, like in MATLAB? In MATLAB Simulink, we are connecting blocks. Likewise, in sim electronics, we connect different electronic devices.
Hmm.
I mean, electronic devices, electronic components in
Yes,
sim
yes,
electronics.
yes, yes.
So, is there any possibility? Can we connect electronic components here?
Yes, ma'am. That's what I try to explain, that all MATLAB functions are there. Like if you see right click on the block diagram, you see a signal processing toolkit. And in signal processing toolkits, these all windows are there, Fourier transform windows. Okay, these waveform measure functions, FFT, Laplace, filter design, signal operations, time frequency analysis. Multiple operations are there. So already there are so many windows. Actually, MATLAB Simulink is copied from the LabVIEW.
Okay.
So all these functions are already, so if you want to go for a mathematical operation, probability, statistics, histograms, mean, median, matrices operations, all these are already present in this.
Yeah. But
Apart from that, you can have on your hardware interface with this library functions.
okay. So, for example, it's a very simple example. For example, there is a ostable multivibrator. Suppose, okay, it's a very simple application.
Yeah.
But suppose if I want to create that ostable multivibrator, is it possible to create here? I
Yes.
mean, using electronic components, not blocks.
Yes, using a electronic component, you can have your timer circuit or RLC circuit on your bench.
Mm-hmm.
And then with a particular controller or a processor, whether it's Arduino, whether it's a Raspberry Pi, you can actually interface with your LabVIEW program, and you can have a real data on your front panel, just like this. So
Okay.
that's possible. So both options are there. Either you want to simulate that particular data without any hardware, that's also possible. So you can have a generated system generated data, or you can have a real data from your hardware setup, and that can be actually displayed on your front panel. So both options are possible now.
Okay, thank you, sir. And one more question, sir. Like in this thing, Simulink and Sim Electronics, there were examples. I mean, they have given projects there, and those projects. I mean, those projects are examples how
Yeah.
to create those projects.
Yeah, correct.
So, such kind of examples are there here.
Yes, ma'am. LabVIEW files help you to give so many inbuilt examples. You can go to the help, just like here, help is there. You can go
Okay.
to find examples. So if I select a find examples, I can find a multiple examples in the search. So suppose now this window is here. So see the analysis of signal processing, mathematics, curve fitting, FFT, frequency, linear algebra, mathematical optimization operations are there. Then you see controls and simulations, case studies, fundamentals of the mathematics. Multiple inbuilt options are there. And apart from that, once you register to ni.com, you make your profile over there. Then automatically there is a NI community. In NI community, there is a several millions engineers who always, like a 24 hours, you will find them working on the solving the students and faculties and industrialists problem. You just post your program that you are stuck at somewhere, you are using this hardware kit and you can't process this data. They will make you a ready-made program within a few minutes. So these type of communities helps our students a lot, and our students daily post their programs that I have made a modified this program, but still I'm stuck over here. They again give you suggestion and send their modified program. So these all community created by the National Instruments. So all National Instruments employees are over there, and many students who are contributing, many engineers who are contributing towards the development of a GUI. They are also posting their programs over there. So that's also a good case for as far as the NA community is considered. Yes.
Yes, sir. Yes, got it, sir. Thank you. Thank you very much, sir, for this wonderful session and a wonderful hands-on. Thank you, sir.
Thanks, ma'am. So any other question? Yes, so if there are no questions, so we can actually start this particular session in full flow from tomorrow onwards, because I believe that many faculties don't have other installation done. till yet. So I believe that it can be done by tomorrow because you have a full day's time. And Megha ma'am, I then request you to, you can conclude the session because
Yes,
it's
sir.
yeah,
Yeah,
already
thank you
time.
so much, sir. Thank you very much. And definitely this hands-on session was quite engaging for all of us. And for audience, the feedback and assessment link for day 1 is already posted here in the chat box. I request you all to please fill it up. And Arpit sir will be available with us in the coming few sessions as well. So we will meet up again on Monday at 10 a.m. in the morning. So I request you all to join on time on Monday at 10 a.m. with the same link. Thank you all. Thank you very much.